Okay, let's do another example here. This one's going to be, well, it's going to look kind of complicated, but it's really not. Once you break it down according to our regular log techniques here, I'm going to say we have 10 times the logarithm base 4 of, we'll say x minus 20 plus the logarithm base 4 of 8 minus logarithm base 4 of 4 squared, and that's all equal to 0. So it looks like a lot, but look at two of these terms. They're really not much. They're just numbers, right? Log base 4 of 8, log base 4 of 4 squared. So let's try combining these terms. Isolating the logarithm is a very popular technique. So what can we do here? Well, let's just leave that 10 log base 4 thing alone for now. Okay, we'll get to that. But on the right side of this, I have plus log of 8 minus log of 16. Well, that's like this. I can combine those two. I don't have to condense everything all at once. I can condense in steps. So I'm going to say log base 4 of what? 8 divided by, well, 4 squared. Instead of 4 squared, I'm just going to write 16, okay? So I don't need to keep saying 4 squared. Log base 4 of 8/16. I'm going to say that equals 0. Well, that's great. Let's keep rewriting this thing. Log base 4 of x minus 20. And we'll subtract the logarithm from each side. So I have negative log base 4 of 8/16, which I'm done writing as 8/16. We're just going to call that 1/2. Now, I've done this on purpose where I brought the logarithm over to the right side with a negative sign in front of it because I don't think we see much of this negative logarithm idea, just negative logarithm of a number. Usually when we have logs of fractions, they're positives. But just to point something out, I'm still in green. Just to point something out, I'm going to rewrite that right side again. And interesting thing about logs is when you have a negative logarithm, remember that's like a -1 power. Okay, if I want, I can think of this here. Let's rewrite this the following way, just to highlight what I'm doing here. I'm going to use this green ink. That's -1 log. And if I want, I can take that coefficient and drop this in the exponent right here, according to the power rule of logarithms. Well, what does that do when you apply something to the -1th power? Remember, if you take something to the -1, that flips it over. So this becomes log of 2/1, or in other words, just 2. So let's write it that way. That looks much nicer. And we're almost ready for logarithmic equality. This one took a little bit of work to get there. The one on the left can be rewritten as log base 4 of x minus 20 to the 10th power by the same power rule. I'm just taking this coefficient of 10 and I'm putting it in that exponent right here. So on the left, I have log base 4 of x minus 20 to the 10. On the right, I've got log base 4 of 2. Okay, cross out your logs by logarithmic equality, and now you have x minus 20 all to the 10th power equals 2, which means x minus 20 equals the 10th root of 2. Okay, and that means x equals the 10th root of 2 plus 20. Okay, and we are all done. One minor note at this point. Some of you may have noticed that I just barreled right through this point right here where I said 10th root of 2. Well, if you remember, when you take the square root of something, there has to be the plus or minus square root. And that goes for 4th roots, 6th root, 8th roots, anything that's an even root. So technically, I should have said x minus 20 equals plus or minus the 10th root of 2. Now, here's why it doesn't matter. If you are going to say x minus 20 equals, we already got the positive solution up here, okay? That's the positive solution. If you're going to say x minus 20 equals negative 10th root of 2, let's imagine this is an alternate solution. And then you plug that, what do we get here? We get x equals 20 minus 10th root of 2. look what happens if we plug that into this equation. Right here, I'm going to pull up this guy. Let's copy this guy, bring it down here. Right there. There we go. This is one of the arguments from the original equation. Okay, plug the solution into it. Let's see what we get. We get 10 log base 4 of, what's x? Well, it's this 20 minus 10th root of 2 thing. And then you still have the minus 20. Well, the 20 and the minus 20 cancel out. So what we get is 10 log base 4 of negative 10th root of 2. That's a negative number. You are not allowed to have negative numbers inside the argument of a logarithm. This is big, big bad right here. So this particular solution does not exist. That is why when you write these solutions, oftentimes, even though you're taking a square root or a 10th root, which is a plus or minus, you have to be mindful of the fact that not every solution you find is going to work in your original equation. So in this case, we really just have that one boxed in red.